We're going to go ahead and take a look at addition and subtraction formulas, as in the sine or cosine of two angles added together, or the sine and cosine of two angles being subtracted. Now, if we look at this over here, we know that 30 and 45 is 75. We know that the cosine of anything is always going to be between 1 and -1. When you take a look at the right side, we want to work that out. Really what we're wondering is, can we basically distribute this through? Because if we did, we'd get the right side. We want to know, can we do that and get it to work out? Well, if we do get it to work out, that's great. If it doesn't, that means it doesn't work. So cosine of 30, you should remember, is root 3 over 2. Cosine of 45, root 2 over 2. And that ends up being approximately 1.57. And obviously cosine of 75 won't be that, because the cosine of anything is always between 1 and -1. So they are not equal. We cannot go ahead and distribute through. That does not work. So then what do we do when we're taking the cosine of a couple angles added together? What we can do is we can go ahead and use the second at the top formula. Cosine of u plus v is really the cosine of u times the cosine of v minus the sine of u times the sine of v. There's a very similar formula above it for the subtraction, but the only difference is you got to switch your signs compared to what you had before when you were adding. Down below, there's another formula for dealing with the sine of a couple angles. Notice the signs match, so when you have the sine of two angles added, there's a plus sign. When it's the sine of two angles subtracted, there's a subtraction sign. Similarly, when we're dealing with tangent of two angles added together, you could look at tangent as sine over cosine, or you could use this formula here. And here's your angle for subtracting. Now, instead of having two separate formulas for the cosine, you could look at it like this, with a plus or a minus. So if you're dealing with the plus, you want to take the top sign, and that's the minus. If you're dealing with two angles being subtracted, that's the bottom sign, so you take the bottom sign over here. And so the bottom three here are really summaries of the top six, written in a slightly shorter way. So here we want to go ahead and look at the sine of 15. You need to think, okay, 15 degrees is which two angles I'm used to working with being subtracted. In this case, it's a 45 minus a 30. If you had thought of a 60 minus a 45, that would have also worked. You would have got the same answer, but your work and the process would be a little bit different. So we have the sine of two angles being subtracted. So you want to go sine of the first angle, because we're going back here, and we're using the fourth formula here in blue, cosine of the second angle. Then you want to go ahead and do the cosine of the first angle, sine of the second angle. And then we want to just work those out. These are all ones you're supposed to have memorized. The sine of 45, cosine of 30, cosine of 45, sine of 30. Fraction times a fraction, multiply the tops, multiply the bottoms. Fraction times a fraction, multiply the tops, multiply the bottoms. If you want, you could write that as one fraction since it's all over 4. We now have the sine of 7 pi over 12. So you need to ask yourself, 7 pi over 12, what two angles have I worked with on my unit circle that would add or subtract together to give me a 7 pi over 12? Well, if you look at your denominator of 12, that'll help you. Because 12 is the least common denominator between a 3 and a 4. Now, we're trying to add two numbers together on the top to get our 7. But you got to think, okay, I have a 12 on the bottom. Well, that ends up being a pi over 3 plus a pi over 4. Because remember, pi over 3 is really 4 pi over 12. Pi over 4 is 3 pi over 12. If we add the tops together, that gives us our 7 pi over 12 that we were looking for up here. So we're going to go ahead to be able to work out 7 pi over 12. We're going to use the sine of a third of a pi plus a fourth of a pi. Then we'll go back and we'll use one of those formulas. So we'll take the sine of the first angle, cosine of the second angle, plus cosine of the first angle, sine of the second angle. Then we're going to go ahead, and all these are ones you're supposed to have memorized. The sine of pi over 3, cosine of pi over 4, cosine of pi over 3, sine of pi over 4. Once again, you're going to multiply your fractions together. You get a 6 inside your root over 4. You get a 1 times your root, or root 2 over 4, so you could write it as one fraction. Well, we can go ahead and use our formulas also for this one here. Yes, we don't know what u is, but we do have the cosine of two angles being subtracted. So we'll do cosine of the first angle, cosine of the second angle, minus sine of the first angle, sine of the second angle. Now, cosine of pi over 2, that's 0. Cosine of u, we don't know, so we'll leave it there. But 0 times anything is 0, so we don't need that. And if you add 0, it doesn't change it. When we look at this part, the sine of pi over 2, we know that's 1. Sine of u, we can't do anything to it. 1 times the sine of u doesn't change it. 0 plus sine of u doesn't change it, so it's the sine of u. Here, once again, we have the cosine of two angles being subtracted. So we're going to use the same formula. Cosine of the first angle, cosine of the second angle. Plus, because remember when you're dealing with cosine, the sign that you have here is always the opposite of this one. Where with sine, they're the same. Sine of the first angle, sine of the last angle. Cosine of theta, we can't change. Cosine of 3 pi over 2, 0. Sine of theta, we can't change. Sine of 3 pi over 2, negative 1. So 0 times your cosine is 0. Then you got to add a negative 1 times this, so it's just really a negative sine theta being with your 0. Your 0 doesn't change it, so we get this. What we have here is a list of our cofunctions. They work with complementary angles. If you go ahead and work this left side out using the sine of two angles being subtracted, you would see it would simplify down to this one on the right. So your cosine of these two gives you your sine. Your cosine of u gives you your sine of these two. Your cotangent of u gives you the tangent of these two. Your cotangent of these two gives you your tangent. Notice in all these, we're dealing with a co, and then it's going to the one that doesn't have the co. Here you have a cosine going to the one that just has the sine. Here you have your tangent, and it's going to the one that has the cotangent. Here in the bottom two, you're dealing with a cosecant here, and it's going to the one that without the co, which is just secant. Those are your cofunctions.